What's up, everybody? Welcome to TeslaFix. Today we have another special episode because when you cover Tesla, you get no rest because of course they released another new video that we have to go through now. In the bot universe, there's happening something, and when we talk about bots, you know who we gotta call.
Welcome to TeslaFix. Make sure to subscribe and like this episode.
Scott Walter is here again, as always. Hi, Scott. You're an aerospace engineer. People might already know you. You were on recently, but hey, what are we going to talk about today?
I think we're going to talk about the Teslabot, Jan, right? So we're going to take a look at what Tesla released over the weekend. As usual, they always have to drop it like some crazy morning hours on a Friday or Saturday or something like that. And then we all have a chance to look at it. Now, you are actually lucky. Let's say you get the take that's maybe 24, 48 hours old, something like that. Because as typical, more news gets generated as you go along, as some of the Tesla management will talk a little bit about this and that. So there's a lot more news than just what came out early on, what was it, Sunday morning, I think, very early Sunday morning.
Yeah. Around that. Yeah, of course, my time zone is a little bit different, so I get no sleep, actually.
Yeah.
That's the hardest thing. Yeah, but Scott, I mean, it was amazing. Maybe we should jump into the video first. Does that make sense? And then
Yes.
we jump over to the kind of tweets that surrounded that. I think that makes a lot of sense, because I think you have to give more than just a few or your 2 cents on this, and let's see what was happening there, because I found the video pretty awesome, of course, as always, as a Tesla fanboy, but you as a robotics expert, this makes sense. So what's happening here?
Okay, well, it's a very simple pick and place operation. So it's something that could almost be done with a standard bot, but you got to start somewhere. And Claudia Moll noticed this kind of in the video that was released, when was it? About 2 months ago, where we could see there were some 4680 batteries on the table, and you're trying to figure out, well, what's the point of that? Because you would think that most of that is something that's already automated. And we'll find out later on that perhaps it's not. But the main thing is getting the bot to be able to do what seems to be a fairly straightforward task, but you got to begin somewhere. And so going through, picking up these simple objects and placing them in the correct pattern. And as we will see, some of the slots, a little bit difficult to just drop them in there. So you are putting a round peg into a round hole, but every now and then you miss a line. And they've seen that they've got enough data in the training set that occasionally when they have a misplacement, it's able to do error correction, which is pretty important. And so we're going to sort of see that here. And this is the bot's point of view. It's a rather interesting kind of fisheye view. But from that's what's coming in from the 2D cameras. And so you've got basically photons in, actions out. And we can see right there, notice it missed something, and it goes ahead and is able to correct that. And we're going to find out later on that there was some comments in posts about that from the people who are working on this overall project itself. Now, another thing we can notice about this is that's a very simple setup. So this is a mock-up that they're able to duplicate in the lab rather than having to go down to the factory floor. So rather than trying to bring some very complicated equipment up there, there's a lot of things you can mock up very easily. So that is emulating an actual conveyor that you would have on the line. And as you notice, it's human powered. So there's kind of some irony there that you have actually a human being that's pushing the batteries on down there to make it appear or behave exactly like what a small belted conveyor would act like in the factory. And I kind of call that person's like the croupier, I think. Is that what it is? When you down in the casinos, just kind of
pushes the chips around. Yeah.
Yes, exactly. So, and then of course we can see off to the side there that there are a lot of teleoperators, somewhere between, I think, 5'7" and 5'11" in height. Because there was like a call for this for a lot of people to do it. And they do have a lot of teleoperators, which they're doing all day. And you're able to notice that the lag between the movements. And this is something I want to point out is that there was some noise today about, everything is teleoperated because at the 44-second mark, you see something there. And it's like, yes, at the 44-second mark, you also see something that says, and these tasks were trained with teleoperation. So they're showing how it's done. It doesn't mean there's no autonomy, because at the very beginning, it's showing autonomy.
Yep.
Tesla is not the only one that is using telerobotics to be able to do this training. They're doing that. What's important and what you see in there, and this is something that Dr. Jim Fan pointed out, is the lag between the teleoperation and what the bot is doing is, it's not noticeable at all. And that's very important because, you think about anything, if you're playing a video game or anything else, and if the response is lagging, your controls going in, everything gets all over the place, right? Because you kind of overcorrect and undercorrect, and you keep on trying to do it to get to be right on. So you've got to get that lag down to zero in order for the training to be done very quickly and without, let's say, error and distortion. Because if you don't, then you are teaching the bot, this is how you pick up a part. You move your hand around like this until you get there, rather than going directly for it. So
they have to be very precise in training, right? They have to do the movement very precise and everything. And of course, I think one point that is interesting here as well is that what people tend to forget is that they are training, as my understanding is, a neural net here. This means they want the bot. They are trained differently. They are not programmed. They are trained. So this means they have to experience that movement to learn it from the movement of the human. That means that's what they are doing here, and that's far from low tech or the wrong approach or like I've seen some comments on X say. It's pretty interesting.
The thing is, there's multiple modalities that you need to use to train. So you could do a little bit in simulation, you do a little bit in real life, and then you do also with the autonomy. So the first thing is you need a diverse training set, and diverse is very important. So if you're having it do the exact same with the same precision each time, then it's not able to handle real world situations where you have variance. So the whole idea is to make it very diverse. So you've got different teleoperators, which are training a little bit differently already. You also have different bots, and while they're built to the same specs, they are not identical. They will be a little bit different. So that's also another big concern is how do you teach one bot and making sure it moves to another, knowing they're not going to be exactly identical. And again, it comes from a diverse training set. And once it's large enough, then you start to get the convergence, and the neural net will figure out what it has to do to be able to accomplish a particular task. But the main thing is that you've got to get that data flywheel going in there. A lot of teleoperators, and a lot of teleoperators means a lot of bots. So one of the first things that we notice from this is that, wow, there's more than one Gen 2 bot out there, or more than two. It seems to be there might be in the order of like a dozen or so that you're kind of distinctly able to go through and count. So, and that's a good start. It seems like you would probably want to have more in the order of maybe 100 to really get that. Now, you might be saying, well, why can't you do this in simulation? Well, it turns out simulation is not the same as the real world. And in many cases, it seems that you get better data convergence when you are training in the real world and doing the autonomy in the real world as opposed to doing millions and millions of iterations in simulation. So the first thing is to get the telerobotic operations in there. And then after that, you start to let it run the autonomy. And that will also start to give a feedback loop that will begin to start training itself. But the first thing is to get it started. And you start with very, very simple tasks. And remember, it was mentioned in the earnings call that they are doing factory type of operations already in the lab, and which we can see they were able to actually duplicate some very small, simple thing that's on the factory floor. And they are actually doing it, testing it in some automation, some factory settings right now. We've seen one. And when we get to the posts, we're going to learn a little bit more about what's going on. So I think right after this, we do see the actions that were taught in the lab now being deployed into the real world situation right here. This is, I guess, a little bit perplexing because everyone says, well, wait a minute, you get a little robot arm that's pulling those canisters off of the conveyor belt. Why can't you just have it go ahead and put it straight into the orange tray there, or build a similar mechanism to be able to do that as well? And that's a really good, very valid question that I had to sort of sit there and think myself, why are they doing that? And first of all, that's not really a robot over there that you see picking that off. Some people might think it's a robot. It's a very simple piece of automation, a piece of equipment that's going over there and doing that. It's so simple. They may or may not have a camera there just to identify the fact that there is something in place. You could also do that with very simple sensors that says there's a can there, pick it off the can, and it does the same thing again and again and again. So you notice the pick up and drop off locations are the same. It doesn't have that many degrees of freedom in there. And you might say, well, that's more than enough to get the job done. So why do you bring in Optimus with 40 actuators when it looks like you do it with 3 or 4? And part of it is that if this is what they actually have that they're on the factory, that is designed for a human operator to pull those off right now. Why haven't they automated it? Because it's very difficult to automate all operations at the same time. It takes a while to kind of go through, and you focus on those areas that are important first. It's also costly to automate something, especially something that's very specific. And so right now, it probably is a manual task that a person goes in there and does that. The other thing is it may be that it doesn't have to run 24/7 doing that operation. It may be limited in the amount of time it does it, because I don't know enough about this part of the line, on whether it's like after testing, whether this may potentially be like a rejection of 4680s that did not pass the test that you need to pull off. The other thing is, I have to ask you, where does that orange tray go when you're done? Any idea? Oh, I think you're muted.
Oh, I'm muted.
Yep.
Okay, I'm muted. Sorry. Yeah. So I think it's. I don't know really, but I assume that it has to go into a machine that picks it up again, or maybe
it's not obvious
somewhere.
See, normally when you have something like that, that will be like on a conveyor of some sort that it automatically moves ahead, or that you push it onto, or you're putting it onto a mobile robot. I'm looking to say, wait, it's going straight onto a table. Where does it go from there, and how does it go from there to wherever something else goes? Well, a human picks it up and probably moves it over there. So you may have an operator coming over, picking those things off, and when the tray is full, lifting it up and then bringing it over to somewhere else. And that's why you need to have Optimus there, because it looks like, it's a one-handed job. So why do you need to have that extra arm that's sitting there doing nothing? What do you need the legs for? Because when it's all done, it's going to need both arms to pick up that tray and both legs to be able to walk over to somewhere else. So this is like a form of drop-in automation, which is the dream of any automation engineer, that you have this off-the-shelf solution that you literally just drop in and you don't have to do anything. So you could attempt to automate that some other ways, but that hard automation will also be far more costly than you think. The other thing is that when you automate a line, in many cases, you are automating in those areas where you're trying to improve quality or speed. And those things where quality is not an issue, like, do you think the product is impacted by how they are dropped into that orange tray?
No.
Yeah. I mean, there are other parts of the operations where a lot of precision and delicacy is needed. At that point, you don't need that much, so you can do it manually.
Yeah, maybe closing the tabs would be a task that's very important.
There are things that you want to automate.
Welding this thing and stuff like this.
Yeah. But a task like this, that's not going to be a source of quality issues. So the reason why you want to have high quality is that low quality costs you money in the end. Returns and failures and everything else. So you automate because it improves quality.
So I have a very stupid question here, but or maybe there are no stupid questions, but is there a possibility that this process was made for Optimus, or do you think it's not? So
no. I think that's probably how it is. So again, we don't know the state of the 4680 line, except they're constantly iterating and moving on that. Yeah. And the what Elon calls the algorithm, the fifth step of the algorithm is don't optimize too early. So a lot of times people are automating processes well before they figured out what the optimal process steps are. So you don't want to go in there and drop in some hard automation, and it turns out that we have to change the whole look of the line, everything, and suddenly you're throwing that thing out. So at that point, that's like a non-critical part of the process. It's probably not something that required a lot of speed or anything like that, because you can see Optimus is able to keep up with a line pretty well at the 1x speed. So you say, at that point, we'll just go ahead and drop a human operator in there until we figure out everything else. And so, and again, it looks to me that really strange is that if that was like high volume production that was going through there, you might automate it, pulling that thing off, or at least make sure when that tray is full, you're able to push it onto a conveyor and bring in the next empty tray and start doing that. So if a person is supposed to be sitting there the whole time, that's exactly how I'd expect it.
Yeah, I also think when there was a good point, maybe batteries that didn't fit the quality criteria, and we've heard, of course, that the yields are there. There are, of course, batteries that fall through that quality check, And this could make sense that
Yeah,
the speed of the line is also not as fast as you would think. We saw those Grumman automation conveyor belts that, because of the Teslabot Grumman automation, they are also from transferring bottles and stuff like this. That they were specialized in those kinds of tasks as well. So of course for batteries that are like cans and you just throw them around, that makes sense to get those. And of course they are very fast. We see the scanners
really fast.
that scan it. Yeah,
it just seems too slow to me. And that it must be something that they fail to test and they're going in and they're either going to be rejected or they're going to, sometimes you'll have like a rework station or something like that where stuff comes out and they try to find out what's wrong with it and you go to do more work. So I'm not sure where the rejection is done. You know, it looks like somewhere further up in the main line, there may have failed a test and then it's gone into kind of this spur that's going around there. And then it's just finally taking it off, putting it into the reject. And those pucks are being then recirculated around so they can pick up the next ones, because we see it looks like every can's a failure there. So that the decision, if it failed, is somewhere upstream and they move around. And you see the output that's there is kind of set up in a way to be a buffer. So in other words, it can accept a fairly large number of cans before you have to empty it out. Because if that conveyor backs up, then it backs up the main line. So you don't want that. Yeah. But the buffer gives you a certain amount of time, which means a human can just like pull a bunch of them off really quick, take the tray and move it off somewhere else while it starts to fill up again and not worry about it blocking the line. So that's why you have buffers like that in there, to make sure you don't have to be perfectly in sync.
And it made a lot of sense, I think, what you said about not to automate too early. That's the main thing Elon said many times before, that they don't do that. And it makes sense because when you have a company that's so agile, if you have new parts, you test lines, you switch over, you have engineers that constantly iterate, and the focus is on iteration. Yes. So this makes sense that you have this kind of low-tech task that a human operator would do, and now you have a bot to do the task for them, so they can focus more on iteration again and focus on planning the next line. And
you can't automate everything at once. It's virtually impossible because there's just so much that has to go on. So you focus on what's the main part. So, the main part is like, well, we want, let's say, a spot welding line that's going in there because that's critical. You don't want manual spot welds because that's where quality issues go. So, okay, we build the spot welding line, but then there's other aspects to it. Like we've got to have these feeders that are going to be loading parts in and out, stuff like that. Well, we can do that manually because we know how to handle that right now, and it's very easy to implement. But we might think of eventually coming up with a way of automating that. And I've seen that already on the Cybertruck line, there are some parts there that are manual right now that they're getting ready to turn over to automate because their suppliers are finally delivering the stuff. And partly it might be because either the supplier is slow or the supplier was told, no, we don't need it right now. We need it 6 to 9 months from now because we got to make sure we iron out the bugs in the main line before this stuff comes in and makes our job even harder. So you first make sure you get that stuff done. So the Cybertruck line is going to continue to get more and more automation in those areas that were not as critical at the beginning. And, hopefully they're not going to like put the brakes on everything and say, wait a minute, we're completely rethinking this whole thing now. So we're going to do it again. So you need to be careful where you are automating, where you're not. And the fact that you have this very deployable sense of automation that you can drop in wherever you want takes a little bit of load off of like having to deal with something, which is, it's kind of way down on the totem pole as far as where it's needed. Yeah.
Yeah, it makes sense. I think a very good explanation for that part. And so let's see what we have also in the video here. What's also funny to me, again, sorry that I interrupt again, that the first iteration was this, and then we have this. I think that's very cool.
What I can't wait is to see Optimus become the croupier. Bring one of them over there.
That's true. Yeah,
running it around.
Yeah, that's true. Yeah, and then suddenly we have a lot of people getting thrown out of Tesla again, or maybe not going maybe to another task. That would make much more sense, of course. Yeah. So and here we have it walking, making regular strolls around the office. Yeah, this is also great. And did you see something here? Was there something special? I think he doesn't walk in a presidential mode now, because he walked in the last video. He kind of walked a little bit strange, especially in the last section of the video we've watched before.
Let's say, maybe just a little bit better. I didn't notice that the walking had really improved that much. Certainly the speed didn't change. And even the picking and placing speeds were not phenomenally fast, but that was then addressed in a post from Milan. So I was like noticing, it's like, okay, I was hoping we'd see some speed improvements, or maybe they're going to address that. And he did. And he said it's because they're working on reliability right now. That's the main focus. And then that speed is just something that will happen over time as they decide to either, the neural nets will get better at this. But the first thing is they don't want it to walk too fast because they don't want it to fall. And right now they're confident enough that it can go for these longer walks and not have to worry about there being any sort of issues. So that's the most important thing. The same thing with the picking and placing is they would like to get that to be almost perfect or close to perfect before you start speeding it up. And of course, it is able to do a little bit of error detection, error correction as necessary. But right now, that's kind of good enough for the task that they have. And eventually it'll go a little bit quicker.
Yeah, makes sense. So I think now is a good time to jump over to the tweets that you've also picked out here, of course. And so which one would you say is...
Well, I guess we could start with Milankovic's. So the first thing to do is that whenever one of these bot videos gets released, wait like 1 or 2 hours and then go to and make sure that Milan hasn't posted something. Usually he does. So he'll add some commentary onto it on things you may have noticed. And so he talks pretty much about the amount of work that they've done. The most important thing is that the manufacturing team has produced the more bots that they need, so they get more to work on, which is very important because it's all about collecting the data. Everything here is end to end, and so things are getting better as far as the precision that they want to have. So that's a pretty important thing to see, and that it's just using the 2D cameras, nothing fancy, no LiDAR or anything like that, which means the neural nets are able to understand the environment pretty well. There's a pair of 2D cameras, which of course is going to give it the what's in effect stereo vision for being able to do the movements. And again, they're just using existing components within Tesla, which is the FSD hardware, to do the training. And that means they're not having to come up with anything special. It's just getting a different network kind of trained. And certainly it's being a bit slow. But we're seeing increasingly high success rates with less frequency of misses, which is good. And so that's a pretty important thing from their standpoint of being able to do it. And also, we've deployed a couple of bots at one of our factories. So we're not just seeing one, there are a couple. And I assume that means different operations in different places that they're looking at. And that falls in line with exactly what Elon had stated, that they're already in the labs and they're getting ready to do some tasks down on the factory floor, and then probably be doing useful work by the end of the year. So we'll be seeing a little bit more of that. It's good that it's not falling. And then so they're going to be making it move faster, more adverse terrains, which is rather interesting from the adverse terrains, whether they're looking at more uneven surfaces, where they're looking at stairs, where they're looking at going on sand and gravel. And the reasons behind that, the rationale, are they encountering adverse terrains in the factory floor? Because usually you'd hope not. They try to keep all those things pretty flat and clean for all the other automation that's in there, and also for safety reasons. It may be that they're looking for doing things outside of just the factory as well. And, repeatability across the fleet. This is pretty important. And the reason why they have the multiple bots, and he talked about something, I think in the very first line, he threw out the line AppropriException. So if we go right up to the top, he's talking about how it worked. And let's see, I think the very first, and so allowing you to do the work when they very precisely, see somewhere in there, remember, okay, it's in the third paragraph, as well as onboard proprioceptive sensors. So that's very important to be able to correlate what you see on the camera with where your arm is. And so that way they're able to kind of calibrate that the position of the arm is exactly where you expect it to be. And this is going to be very important for being able to take end-to-end learning and move it from one bot to another. And this is the calibration step from one to the other. And so they're talking about cross-fleet things down at the bottom. It's like, we trained it on this bot, and now we want to deploy it to all 20, and we want them to all work and not suddenly start failing because it's like, well, wait a minute, it's only going to work in the bot that you trained it on.
That's why that was the video where the bot looked at its hands, and then it's saw the joints, the movements where they are, the proprioception that we were talking about. So the bot is mapping where the hands is to get a kind of a null or a 0 point where it starts, and then it starts the movement from there. And that has to be consistent. And now kind of I really get why Tesla wants to mass produce these things, because the error will be lower in mass production when you start to produce this
it comes
thing
down
massively.
to the training set.
And then you have if you have just prototypes, the hand-built prototypes, there might be some errors in your hand building. Some screws might not be tightened enough there, and there's a little bit jiggliness over there. I think you can perfect it, but it will take a lot of time. I think it makes sense to have
it's going to change even within the bots.
Yeah.
So it's very important to be able to do that from the coordination, because they're talking about end to end of photons in, joints out. And if the joint values you have to give are different from each robot because their encoder zero position is a little bit different, you've got to compensate for that. But you're also going to get drifting within the same bot. So over time, that bot's going to change if you've done any maintenance on it. Temperature differences, just things start getting worn out. So you need to be able to adapt to that, and not so it always works for the same bot, let alone for the entire fleet. So that's kind of what they're working on, is making sure that things that are taught or one can then be deployed really quickly. Now, if they have like a major change between the configuration of the bots, one that's a little bit taller or something like that, that's a good question of whether they'd be able to do that mapping. They should be able to, but there'll be some cases in which, if it's so radically different, like, you do these trainings, say, let's bring it to a robot dog. It's like, I don't think it's going to work. It's just kinematically so different. You're going to just have to train things with a robot dog, and you're not going to be able to take it from Optimus.
Now, I was wondering, because this proprioception topic came up, what about the new Atlas? This one has a total different range of movement. It can go, the hip goes 360 degrees to the backside, or the arms. No, what was it? It
basically,
turns around.
the hip is able
the hips.
Basically, if you take your knees. Yeah. So what you're doing is that if you're able to take your body and have your knees forward, what can you do to make your knees go to left or right?
It can turn around, exactly.
Now, imagine being able to do that. I can do it a little bit to the right. And I can't quite get it to go all the way behind me because, my rotation is limited. All they've done is said, let's open that up. Let's make it more than the human can do. And they did the same thing with the arm. Basically, they took this joint here with your arm. So my arm is kind of straight out like that. I can kind of rotate it this way, back and forth. All they did is say, make it a bit more. So rather than the elbow only being able to point so far, we can completely bring it around the other way. And that allows you to, in a sense, mirror the entire human body. Yeah. So your front becomes your back, and your back becomes your front.
Yeah, exactly. And I think with all this turning radius, do you think where is the 0 point? Is that hard to map?
There's a reference location for this. So at some point they'll know where that is. Yeah. Okay. So they'll have the encoders that can do the count. And again, it's something that the Teslabot could probably also do, because it has some similar degrees of freedom there. And they've just limited the movement there, and it could be limited for a couple of reasons. One is that they just don't want it to do that. And the other is that you have to deal with the fact that there's cabling going through there. So, if you wrap the legs up too much, you may not be able to do it. But it's not, if Tesla wanted to do the same thing, and not just Tesla, like almost all the other human bots are out there. If they want to do that same party trick, they probably could.
Okay. Yeah, but I was thinking about the proprioception, if that is limiting maybe, or more complicated because it has more degrees of freedom, or
the range of motion. It's generally not a problem. Maybe, it depends on how your encoders are set up, because we know you have this ambiguity in my head, 0 degrees or 360 degrees. And usually they do that just by counting the encounters that they know that they've kind of passed where they are. Yes. They know I've got a wrap. Yeah. And it's like, just add a wrap or subtract a wrap.
Okay, good.
I just wanted probably doing something like that too, because you've got gearing going on. So depending upon where you measure, sometimes they actually measure where the rotation is happening, not at the end, where it comes out of the gearbox. So the gearbox might only have a range of motion of plus or minus 90, but your motors might be spinning way more. They may be doing multiple revolutions. And so if you're measuring right there on the shaft, your encoders have to count that. So they know when they do a wrap, they're keeping a bit in there and say, we went over one, twice, three.
Okay. Okay, this makes sense. I just wanted to know. So, okay, back to the Teslabot. I mean, now we've looked at here the first comment of Milan, who works on the bot. So this is very interesting. And what else do you think is important? We also have here
we have one from Julian Ibarat, who also works on the team, but basically confirmed a lot of what Milan says, like, the multiple bots that are on there and reliability. So it was just kind of good to hear the same thing coming from two members of that team that are in sync on that. So, reliability seems to be very important, and that, some of the learned behaviors that they're beginning to come is rather interesting. Especially like it seems that the corrective action was more or less an emergent kind of thing as opposed to something that they coded in or expecting. And he also talked about that, was able to run for hours until they needed to recharge the battery. So that's a good thing to hear as well. That and that's what you need to have the autonomy in the factory, especially if you don't have the luxury of being in the same location that you could be plugged in permanently.
Yeah, maybe the batteries that we saw were hot swappable batteries for the Teslabot. Who knows? Or for producing the packs.
I don't think those batteries you see there. I don't think those are the batteries that actually go into Optimus. Optimus, at least the first gen was 2170s. And we were able to confirm that. They may have switched it up. Who knows? But I think they're still 21.
Yeah, it wouldn't make sense. I think it wouldn't. I mean, Cybertruck is top priority right now, and I think everyone will go into the Cybertruck.
Yes,
that's true. Yeah, they changed it. I had the initial thought that they had the 4680s, which would make sense, but maybe in the future. But at first, it's all Cybertruck here. Or Megapacks maybe later. If some of the yields are not as good, then they could use some of them maybe for the Megapacks. Yeah, interesting. I think it's so interesting how Tesla improved in this short period of time, and we saw some indications at first. I mean, the famous folding video that made people furious because they saw a hand on the right suddenly. It's teleoperated. They lied, but they confirmed it afterwards again. Like, it's teleoperated. It's just the video.
Now in this video, we see one Gen 2 bot, and then we see a bunch of Gen 1s hanging there. So I think that looks like 3 of the Gen 1s hanging around there. So, that was rather interesting. Whereas in the latest video, I could not see any of the Gen 1s. So it looks like they've been retired, and now they have an adequate set of the Gen 2 bots to be able to use for their training. And then we had some more posts to come right after this. Again, sometimes it's why it's best to wait a few hours before coming up with a hot take, because it turned out right after I was on the live stream with Herbert. We get a couple. One of these came out just before a live stream, and one of them came after. And the first one is that the new Optimus hand later this year will have 22 degrees of freedom. So it's something we need to break down. And then a little bit after that, we learn a little bit about how that's going to be done and what's important. So let me ask you, how many degrees of freedom does the current Optimus hand have?
1, 2. Wait a second. Rotation.
Okay, you know what
counting the fingers in. Counting the fingers,
but not the. So what you want to talk about is the difference between degrees of freedom and degrees of control, or the number of actuators that you have. The simple answer right now is that Optimus has more degrees of freedom than your right hand.
Okay.
You want to show everyone your right hand?
Especially now.
Okay. So now, but not as many as mine. I actually have more degrees of freedom. Okay. So right now they have 11 degrees of freedom, and they're counting them as these different joints that are able to move. So the fingers have 2 knuckles on them rather than 3 as a way of
Mhm.
simplifying the whole thing. The idea is like, the best part is no part. So, do we actually need to have 3 knuckles in our fingers or not? And then they have only the ability to sort of move the fingers forward this way. And as you have an actuator that moves an individual finger, it causes the finger to curl. So you have like a degree of freedom here and a degree of freedom there, but one actuator doing that. So they have 6
Mhm.
actuators, but 11 degrees of freedom. And the thumb has an additional degree of freedom over the fingers. And that is, rather than just moving one direction, it can also move in another. So they already have built in 2 degrees of freedom there, where the Optimus hand can only do this. Now they're going to 22 degrees of freedom. They're doubling the total number. The question is, where is that coming from? So let's kind of go through that. Right now, we have for each finger basically 2 knuckles. This last knuckle here, they froze in place, and then they changed the length of the finger to kind of make up for the fact that you took away a knuckle. So it's not quite 1-to-1 to a human hand. It's a little bit different. So a movement there, that's 2 per finger. That gives you 8. And then you say, well, then a thumb gives you another 2, right? That's 10 plus the extra one. That's where you get the 11. Okay, so what are they going to do with a hand? Well, it seems like they're probably going to add a knuckle to these fingers up here.
Mm-hmm.
And they're going to allow the hand to do more than just this movement. They're going to allow it to do that.
Ah, okay.
So now the question is whether they can do this. I don't know. We're going to find out. So
very important for Star Trek conventions.
Star Trek
of course,
fans,
yeah.
exactly. So the
Vulcans.
Vulcan live long and prosper salute. So can it do that? So they're going to add 1 degree of freedom there, and basically another movement here. So that means 4 degrees of freedom per finger. 4 fingers, that gives us 16. Now, if you look at your thumb really just has 2 knuckles as far as you're concerned. There's kind of another one buried down here, which is why you get that movement in here. But for all intents and purposes, I don't think they're going to change the degrees of freedom on their thumb. So we got 4 times 4 there, plus another 4, that's 20. We're missing 2. Now, they made it very clear it's the hand that's going to have it. Sometimes when people talk about the degrees of freedom of a human hand, they say that it has 27 total degrees of freedom. And they're counting 3 degrees of freedom at the wrist. I don't think they're counting, they're throwing the wrist in there. Right. So it could mean that they're going to get some flex in the palm. Okay. Because it turns out the human hand, we do have some movement in the palm as well, not just in our
that's
fingers.
true.
So there's a little bit there. So that's a possibility that they're doing it. So why don't they have that in the palm right now? Well, there's a good reason they don't have it in the palm right now. Do you know what that is, John?
You're about to tell me. I have no clue.
All right. Because remember, in order for these fingers to move, we need actuators to do that. And we got to stuff those actuators somewhere. Well, the actuators are like right here. So basically, there's an actuator coming down from each of these fingers like this. And then there's also one for the thumb and a cross one for the thumb. So that means they're all packed in there. And because of that, your palm isn't flexible. There's no way you can make it flexible because you've got these motors that are moving this way and one that's kind of that. There's just no way you could make the palm curl or scrunch or do anything like that. Because
what is it this year? Also, like
so you've got a joint right there in the thumb. So the thumb has 2 degrees of freedom. It's able to move this way and that way. So it's got kind of two movements that are very important for the thumb. The fingers you can almost get away with only having to curl. So now the question is there something to allow the palm to kind of crunch down like that, or some additional strange degree of freedom they're putting in there? And how are they going to actuate them? Are they going to just use 6 actuators as before, which is possible, but it doesn't make sense because if they added a knuckle to each of these, make the fingers more natural in their movement, you don't need any extra actuator. But if suddenly you're doing this with your fingers, and I'm pretty sure they're adding that degree of freedom because that's the only way you can kind of get to that 22. That means you need something to actuate that. You would need a motor to do it. And the question is, are they going to have one motor that makes them all move out at the same time? And for most people, when you go to move your fingers, they almost kind of all move together. That's the more natural way of doing it. However, if you really concentrate hard, you can kind of make them move individually. So that means to do that, you would need an actuator for each one of them. So are we going to add 4 more on there? So suddenly we go from 6 to 10, or are we going to go from 6 to 7? That's like one of the big questions, what they're going to do that. And then we haven't got into whether, the other kind of different movements that you can have in your fingers. So right now, what they have is they've got an actuator down here and they've got a tendon attached to it. And the tendon goes through here. And as you pull on the tendon, it causes the finger to collapse like that. So you're pulling on it. And that means each of these knuckles just moves on its own, moves as a result of that. And you cannot independently make them move. And that's kind of the way it is for most of us. But if you concentrate hard enough, I can kind of take my finger, keep it straight and rotate it about this joint right here. Okay. So I do have that ability, especially if I want to play the piano. If I want to play the piano, I need to go get my fingers out, maybe kind of adjust them this way. And I'm pushing them down like that. I'm not doing this when I'm playing the piano. I want to be doing something like that. If I'm grabbing a Coke can, I just want to do something like this. So the question is, are they going to come up with it so that they can actually keep the finger straight while doing that? Or is the finger just going to curl all the time when they move down there? To do that, you need a little bit more control. You need some more motors to be able to do it. So I'm pretty sure they're going to have at least 7 actuators. Okay. So they're going from 6 to at least 7. The question is like, are they moving higher up and are they going to have, well, let's see, we need to have 4 there. So that would mean already 10. And then if you get something going on down here at the palm, which I'm trying to figure out something going down the palm, how do you kind of actuate that? And where are you going to stuff all that stuff? And especially where are you going to stuff all that stuff if the palm is suddenly going to be flexible? So, and what's the answer to that?
Ta-ta-ta-ta. Here we have
Teslabot team has got a trick up their sleeve.
Yeah. Was it this one?
Yes. The actuators will move almost entirely into the forearm, just like how humans work. All right. So that's their trick up the sleeve, is they're literally moving it up here into the forearm. Now, that means they're probably going to have to change the design of that forearm a little bit. I think they have space potentially to put it there right now. Some of that space is taken up by the structure that they have right in there. It's a pretty solid structure. And we know they have those famous 2 black motors to the side that allows the wrist to move. So you can see the white part that's in there. That's going to be a bit crowded. So they have actually 2 parts. If you might see, there's a little bit of an arc down there that right up by the elbow. There's an actuator built in there that causes the entire arm to rotate.
Yeah, this one.
Now, the human arm, when we rotate our wrist that way, our entire arm deforms. In the case of the robot, it just rotates about that position. So it's solid, kind of partway down from the elbow out to the wrist. That means when you have that roll of the wrist, you don't have to worry about wires or anything getting all twisted up. Okay. Like you would with us. So they're going to have their tendons coming back. So remember, the fingers are already tendon controlled. So it's not a big deal to say, let's move the actuators back into here, and then the question is like, oh my God, how are we going to, connect them and control them? It's like, just make the wires a little bit longer. Okay. Or the tendons in that case that are coming through.
Yeah. I mean, how are we doing it? I mean, we also have tendons that push, pull, and you can feel it when you hold your hand here and move your fingers, you feel the tendons that are inside of your...
These are all the actuators. Now, the one thing they may be doing is that if the whole forearm in the hand is considered to be more like the whole hand right now, because usually we consider the wrist and then after the wrist, the hand. And we have 2 degrees of freedom that are at the wrist. The third one is up by the elbow. Okay. So if you want to think of the hand as almost starting after the roll of the wrist and everything else, maybe that is where they're getting the other 2 degrees of freedom from. But let's say right now, they're not counting those as part of the hand. When they say 11 degrees of freedom, they're not counting the 2 that are the wrist. So if you're using the same kind of philosophy or whatever as how you're counting the degrees of freedom of the hand, you may not throw that in there. But you could be if you're beginning to consider that to be kind of an entire unit there, which means there might be a slight change to the design of the wrist, especially to accommodate everything they need for the actuators in there. However, the wrist design, if you look at the wrist design right now, it's very accommodating for being able to run some sort of cabling through there to get out to the fingers because you've got open area to run it through. This is different than many other wrist designs you see where you have these different actuators stacked on top of one another. The only way you could run those cables around there is you'd have to have this big loop that comes around. So you think of like your bicycle cables, right? Sometimes where your brakes are, where the handlebars are, you got this big sheath that runs around, it's like nowhere near where the joint is, just because that's where you need to get it out. So rather than have that dangling out, which would be a horrible solution because it's just there to snag on things, you want to be able to kind of keep it enclosed through a sheath. They get plenty of room to run it through there. So it'll fit in there and it won't be bulky. And it may be that they're completely rethinking that whole lower arm of the hand and the lower arm as being one unit, because you got a packing problem there. I mean, we can see there's some space in there that you can put some actuators, but unless they're coming up with a completely different actuator design or something really clever that works almost like our muscles to be able to pull on these different tendons, it's going to be rather interesting. So is it, and so they're moving most of them back. So maybe they're leaving like, one of the actuators for the thumbs or something like that where they currently are, and something different for the fingers. That's a possibility, which may or may not allow the palm to be able to flex, but I think the palm will be able to flex.
Okay. So that's interesting, because the flexing of the palm, I don't think I have seen that. I've have to think. I've seen, of course, some hydraulic hands where it's also with kind of with tenons, and they are like pushed hydraulically, but it was a very complex system of loops and cabling, of course, to get it moving, and it's. Now, it looks very human-like, but I think it's difficult a little bit. There are some difficulties there.
Yeah,
and you think it's like tenons, just strings pulling.
That's how it's working now. So right now that's how it's working. And the way it works is that at each joint they actually have built in a spring mechanism. So when the tendon is relaxed, the finger automatically opens up. So there is no tendon you pull back on to open it. Now, who knows? Maybe they come up with some other clever way to be able to get the end. But for the most part, you have a lot of clamping force, but you don't have a lot like this. And again, if you think of like an alligator or a crocodile, that it's very easy to keep their mouths closed. They can't open their mouths, right? That's why you can tape them shut really easily. Yeah. However, you don't want to put your finger underneath it because the clamping force they have is incredible. So that's the same way our hands work. Our hands work really well in one direction, but really poor in the other. And the way the Teslabot and the others do it is they just put a spring mechanism in there that allows it to pop open when you undo the tension on the string. But when you pull on the string, you're going to end up getting it to flex down. And then again, you can put some other things in there, and they're probably worked out some clever way of being able to get tendons in there that as you pull on them, you may be able to get some very interesting combinations, which we'll have to see. Now, the other big question I have is, at first Tesla was like, the best part is no part. Yeah. To minimize your skews and everything else, which is why they had 2 knuckles instead of 3. And everyone else kind of followed suit. They said, the same thing. You probably don't need that many degrees of freedom. They didn't have any sensors in there. Now they have sensors and in Gen 2, but it's still 2 knuckles, and the fingers are all the same length. Now they may appear to be a different length just through a trick. And the trick is that along the palm, it's not flat. Where the fingers are attached, it's along kind of a little bit of a curve that gives the impression that the hand has the same kind of shape. But, our pinky is a lot shorter than our other fingers. Our pinky also is not as wide as the others. So I wonder, are they actually going to emulate the human hand down to that the morphology is very similar, that you have different lengths, which means you're going to have more parts. They've already decided, all right, we're adding another knuckle. That's already more parts. The question is, all right, now do you want to have, unique parts for all of them, or do you want to have them interchangeable? And if they're going that route, I'm beginning to wonder if they're going to be thinking of doing the same thing with the actuators. Because remember, they took the actuators and distilled them down to just having basically 6 plus 1 for the hand. So a special actuator for that. And now are they going to look at it and say, maybe some of those motors that we have up on the shoulder, maybe one of those, we can scale it down a little bit or make some sort of adjustments. Because the problem when you optimize, none of the motors are optimized for that particular one. They're optimized kind of for this and the others. And they may be saying, there could be, maybe we'll bite the bullet and go ahead and have 10 different actuator designs. Who knows? The same thing with the fingers. I mean, they're using the same actuators right now, but are they going to have maybe a class of 2 or 3 different kinds of actuators for what they need to do. Because in some cases, you want a lot of force when you do this, but how much do I need to do that? Do I need an actuator that's that big? It's just about getting my finger out to where I need it to be and to hold into place. So those are a lot of the questions I have of how they're going to design it and some of the design trade-offs they're going to do. And can you think of anything else?
Yeah, I think it's interesting, the approach, because for me, what's stuck to my head the most is the best part is no part. And I also try to figure out why is simplification now not the route? Why is complexity now the route? That you have more.
Yes.
Yeah, because maybe the human that operates it, that you have some errors there. Is it that it has to be more humanoid to learn better? Maybe. Well, I don't know.
Let's go back to Elon's algorithm. The whole idea of you keep on taking parts out, and you keep on taking parts out until you've taken so many out, you have to start putting some back in.
That's true.
So that's the whole thing, is that you don't know if you've optimized enough. If it still works, then you can take another part out. And if it still works, then you can, and then you take one and say, oh, stop working. Oh, I guess that part's got to go back in. So at first they were looking at it very big, and you can see in Walter Isaacson's book, they said, no, get it down to what is the minimum viable product, and we'll build up from there. And there has been a lot of debate. Figure look at it the other way. They thought for sure they needed sensors. They think they don't need sensors. So they're thinking of not having it. Tesla went the other way. And a lot of it's the use case. So I'm always seeing discussions on X, and no one's wrong, but at the same time, no one's right on this discussion of like, do you need legs or not? Should they be wheeled or not? And stuff like that. And it's like, it's a really nuanced question and depends upon the use case. And remember, the whole idea of the humanoid bot, the reason why they're building it is not for a specific use case, but for a general use case. And if you really take the general use case to the extreme, then the wheels make absolutely no sense. And a lot of these other things that you're doing make absolutely no sense. If you become very specific, you can say a really dumb hand will work, a dumb hand without sensors. And maybe if you want, just throw the torso onto some sort of mount with wheels on it. But if we want to be general purpose, and the best thing is start general. And then once you see it's working really well, it's like, oh, we're going to have a bunch of bots that are making iPhones, right, along this line. And they just have to stand there all day. Then you'll say, take the legs off, okay? But right now, we want to be able to have this bot do a variety of different things. And then when you get to that scale, then you can start simplifying it for that specific use case. But for the general use case, it makes absolutely no sense. So that's why I don't want to criticize anyone when they bring up this whole point of wheels, or like, why do you even need them? Why don't we stay? It's like, yeah, absolutely. There's going to be those cases. And we're seeing that Optimus sitting there, just taking the batteries off there. It's like, and the left arm sitting there doing nothing. Why are we paying for it? And why are the legs there? Well, you don't need them. It's like, well, because it may actually be doing more than that. Like we say, picking up the tray afterwards and stuff like that.
Yeah, of course, because it's like the whole, the whole body as well is also like connected more. If you don't have these legs, what's happening then? Because it has to replace a human after all. And
yes. And the other question is it dedicated to that task? If it's dedicated to that task, it can take off one arm, it can do this, that, and everything else. But if the idea is it goes over there for 5 minutes, and then it has to go over there and do something else, and then another thing, and first to go from here to there, you need legs, you need mobility of some sort. And if you could say, well, if it's across a flat floor, well, let's give it wheels. Yeah, but what if it's upstairs and I don't have an elevator? It's like, okay, I guess
and also uneven terrain, then legs might make sense. Of course,
the next operation needs 2 hands, and this and that. So the idea is that if it's a deployable resource, it has to be general purpose. If it's specific, you can kind of cut that down there. So now this is like a long answer to your question. You're just like, well, wait a minute, why are they putting all these things in? Because they're thinking way more general than the factory floor. We've been saying they're looking at the factory floor. Elon has been talking about, these other things. And we said, oh yeah, but that'll come in 10 years. Right now, they're just going to be seeing it. They may be seeing enough that they're thinking, hey, you know what? We can probably start doing it. And you go back to that video, they were showing something other than sorting batteries. Did you see a laundry basket there?
Yeah, and not even
Mertz
that.
is going to be very happy with the scene there with the laundry basket.
The main concern,
Yes, and you were also seeing like these cubby holes with like shampoo bottles and stuff like that. It's like, wow, that's a lot like going to store and shopping and trying to put things away. Here. So they are looking beyond that they see there could be these cases outside of the factory floor. So the robot has to be general purpose, which probably means you need to have a better hand. Now, does that mean that's going to be the Optimus hand going forward? I don't know. It may be that's a more expensive upgrade, just like you have the performance option on your Tesla.
Yeah.
It might come with 2 different hand designs.
Performance hand, yeah.
Because, for being able to just lift batteries out and do that all day, you don't need a 22 degree freedom hand. You can probably do fine with that. Some would argue you could even do it with a 4-finger hand rather than a 5-finger hand. So there may be different versions, but again, the problem is if you have too much variety, that also creates a cost to go up. So sometimes you don't mind the fact that you sort of have overkill for one particular application because overall it's cheaper to just keep on manufacturing the same thing.
Mm-hmm. That's true. And also what I see here is that when you have the humanoid movement solved, then you can maybe have a iteration and evolution out of that, maybe a different kind of hands for different kind of tasks, something like this, a very specialized task maybe with a different hand that makes sense. I don't know, like a huge clamp as a hand, but I don't know, maybe just use tools that could also be, we also do that. So
what we don't know is that, right now FSD is working across the sexy line. It's not working for the Cybertruck. Because the Cybertruck is different than those, enough different that it's not ready to work. They need the training data.
Especially with the small front-facing camera as well, that is down below on the bumper.
So if we build an Optimus with 2 different types of hands, does that mean we have to completely retrain the new Optimus with that? So every time you come out with a new one, it's like, oh my goodness, a whole new training set. So these are the trade-offs you can be thinking about. And that's why, Optimus may just come in 1 or 2 varieties. And even though you say, yeah, but I really don't need a 22 degree freedom hand, so it doesn't matter, because if we dumb it down, then what that means is we have to retrain it, and that's going to be more costly than just giving everyone the 22 degree freedom hand. Now, maybe you go in there and turn off some capabilities of that 22 degree freedom hand, just like they do with like the performance upgrade. It's in there. It's just a software lock that takes it out, but you make sure your training set is sort of targeted towards it. And again, it's so much easier to come up with a production line that produces one part. That's it. It just produces it, and it produces it really well. But then everyone says, "Oh, well, I need to have this." I mean, there's a couple of reasons why Henry Ford said, any color you want except, so long as it's black. It just makes it so much easier. And paint shops with different colors, man, that's a headache. It really is, and believe it or not, every color of paint it's not as easy as changing the color of the paint that goes in for that. You literally have to go and touch up the entire process, because all the spray parameters, everything just changes a little bit. You get different quality for white paint versus black paint and everything else. This is why Tesla's been so slow to roll out different color paints, because you really, really have to go in and make sure you get that process down to perfection. And it's going to be the same thing if you start changing the kind of appearances or the sizes of your bots, is that you may have that problem. So you're going to be like, nope, cookie cutter, keep it the same way. And again, looking at Elon's algorithm, what do you need to put in? What do you not? And I'm sure they were like, really need the 22 degree freedom hand, and it's like, either do it now or we're going to wait a long time. So they probably decided, go ahead and jump into it now.
In work, you've mentioned the paint shop. It makes sense that there are different approaches, for example. I mean, I get your point. Now I'm at paint shops now and thinking about that as well. But I think just a side note, foiling the vehicle or wrapping the vehicle, also makes sense. Maybe even get the step into a process. Maybe in the line could be easier. Maybe the panels, especially with the Cybertruck, with the flat surfaces. Yeah, but who knows?
The idea is like, oh, we're gonna have this line for a car, and we're gonna have a convertible version of it, and you think, oh, that'd be really easy to do, and it's kind of complicated. And actually, the way Chrysler and others, the way they built the car. And after the car came off the line, they took the roof off to make it into a convertible.
Jesus.
Yes. So,
oh God, that's not the automation you like.
It was better to do it that way. And of course, you can do that right now with a Model 3 is you just take it to some shop and they will do the conversion for you. But that's basically what, in many cases, what they were doing. That unless you are designing a car which is exclusively a convertible, if you've got like 2 versions of it, you're better off just build the main one, because 5%, 2% of the people want the convertible.
Yeah. Another thing for the pile of scrap metal then, yeah. But yeah, Scott, I think it was very interesting to dive into the Teslabot here and to see the improvements that Tesla made, and we've seen, general purpose bots now also doing different tasks than just the factory line, and I think this will be a big future. So what do you think what the next steps would be? I mean, we've heard it already with the 22 degrees of freedom in the hands. I mean, this is a big one. But what do you see that Tesla needs to improve, or the next phase would be? You've mentioned speed, for example, that
walking
speed. Walk a little bit, speed a little bit faster.
I think, the walking speed would be nice. I don't see that they need to add any more degrees of freedom. I mean, where could they add another degree of freedom? And when I've asked this to, some of the other different CEOs, the one sometimes we hear is this idea of the scapula, where you could put that in and how important that is. I mean, that's a little bit of complexity. And again, it'll come down to, is it worth throwing that thing in there to kind of slow the thing down and add more cost and complexity? So in other words, you make your 7 degree of freedom arm actually become an 8 degree of freedom arm. It's good in some cases. The legs, I don't think you needed too much unless there's something they want to do in the foot or down at the ankles that may allow them to get a bit more speed out of it. That's maybe something like that. I don't know if they have to do sort of a redesign around the thigh area for the leg extension. I think the leg extension is fine. That there's could be some modifications, but if they're really designing they're redesigning the whole forearm. There's no doubt about that.
Yeah.
And if they're doing that, they must be also going way up the whole tree and everything else and deciding a few other things. And of course, as I kidded before, do you want to add one more degree of freedom to the head? So, if Optimus is going to be playing soccer, it needs that for the header to get that right. So right now it does this and that, questions where it needs to be there. And it also, I think from the cameras that were in there, we could sort of see why it might want to move its head, because when we were looking at that fisheye, it was pretty much in focus in the middle, but as you kind of go out, things get a little bit blurry, kind of like our own vision. And it's like, oh, wait a minute, you need to kind of be able to look at what you're doing at your job. And so that could be a reason why they have some sort of movement there. The only other place potentially they could add a degree of freedom might be somewhere in the torso to allow it to have a bit more flexibility that would make it easier for it to get into a car. So if you're looking at it to be able to kind of get in, to be able to get down in it. So it can drop its head down, which is a little bit easier, but it doesn't quite have the movement in the torso. But when you do that, you are limiting the torso volume that you have, especially if that's being taken up by a battery pack. So depending upon the amount of energy you would like it to consume and the longevity, you're going to have trade-offs like that. And you're still muted.
Absolutely, yeah. That's what I wanted to say. Yeah, but interesting stuff. I think the Teslabot is on a good trajectory, and we've seen it with the last episode we did with the Atlas bot, the new one. I think it's a good development that we see that the robotics companies now kind of woke up again. I mean, you are in the business for way longer than most of the people I even know, because you're such a good robotics expert, in my opinion. I love to have you on. And how do you see that? I mean, did Tesla push it? Is it different now? We've talked about that briefly in the last episode as well that you were on. But do you think it's on the right path? You saw some movement. You told us last time, but I think that's also very interesting. Yeah,
the movement is there, and I'm sure you're always looking 2 or 3 generations ahead. The question is whether there's going to be a Gen 3 by the end of this year or whether it comes a little bit later. It sounds to me, if they're already talking about 22-degree freedom hand, there's a bit of other stuff that's kind of going on. They may not be showing us everything that they're really doing. They're showing us the most boring kind of factory automation because they don't really want everyone to see the other stuff they could potentially be doing. And we had an interview last week with Gordy Rose of Sanctuary. And
nice.
And part of the interview talked about Elon and the Teslabot and whether he saw them as competition. And he had nothing but praise for Elon. And part of it was he said, and this is sort of what we said, is that like until Tesla started to do this, no one took the humanoid bot space seriously. And so they're saying, he wants them to succeed because the more they succeed, the more we succeed. the more people realize that this is really the way to go. Now, there has some sort of differences on the approach, and I think that's fine because it's such a huge TAM. Whenever anyone is putting together products that seem similar, they're realizing there are different markets, and sometimes it makes sense to go after a particular niche that others aren't going after, or you may see that we can really specialize and we understand that one really well, and it's huge. I mean, look at logistics. I mean, just plain going into logistics center, the amount of work they're going there. So if you get bots that are kind of heavily optimized for that, you'll be fine. You'll be fine probably for decades just going in there. And of course, you'll get enough experience that you can then eventually come up with maybe something that starts to overlap what your competitor does. But that's going to be way down the road. So, and that's what I've always felt is like these people are more colleagues than they are competitors. And to see someone heaping on that praise to Elon, it was just like, it was kind of a breath of fresh air and say, yes, he was validating a lot of the things that we had noticed that we felt was out there. We thought, are we the only ones that are noticing this? And then when you see an insider sort of noticing the same thing, it's nice to get that kind of confirmation.
Yeah, it's a great exposure as well, even just from the exposure perspective, because there's so much hype around Tesla all the time, or noise maybe as well. But I think it's interesting because the approach that doing a bot that is more general in the sense that it can do different tasks. It's more human-like kind of. Do you need these degrees of freedom? You can ask yourself, but because it adds complexity. But it's true. I mean, everything we've built as humans is meant to be used by humans, and that this means we have to change the factory floor for the bots. I mean, that's what we did before. We had specialized bots for specialized tasks. We built cages around those things that they can move very fast. We have bots that lift things way bigger than humans can. We have tools that humans can get into and stuff like this. So it makes sense to have a kind of generalized option here. And also on the interaction with the cage, like we've talked the first time you went on my channel, that's also fed by a human that also uses tools to lift heavy things. And that's also a thing where a bot could use, because then it doesn't need to have potentially this strength to lift up, I don't know, 50 pounds or something like this, or 60, 70 pounds.
You will see it. You will see different kinds of phenotypes out there, no doubt about it. So you will see some that are big, Brutus, very strong kind of bots to be able to certain limited tasks. You'll see others that are going to be specialists on certain things. Like, there's a reason why we always kept cats around the house, right? And that was to catch all the mice. So there's no reason why you wouldn't have like some small little robot to go around and catch any sort of vermin or something like that
a spot
you want to get
running
out.
around.
Yeah,
spot
like,
robot dog.
Or just like things that go inside your walls and crawl around your walls constantly to make sure, constantly inspecting to make sure everything is all right. And it's like, so you can imagine that there will be these different kinds of bots, but right now the most important thing for what people are seeing is coming up with something that is in a human form factor, partly because we're more comfortable dealing with a true human form factor. So if you have a bot that's coming up that's on wheels, you may or may not like it. It's going to be more accepted if it has 2 arms like you do and doesn't have 8 arms or something like that, and with like eyes all the way around. It might just be a bit kind of strange. So you want to have something which is able to socialize a lot more easily, and of course be able to work in a human workspaces. But eventually the factories will evolve to match the fact that these humanoid forms are actually autonomous forms as opposed to biological forms, where you have to treat both of them a little bit differently. And that means eventually, humans won't be needed in the factories. And if they come in there, they won't be able to do anything because it's like too dangerous for us to go in there. Whereas the humanoid bot can run in there. I mean, just think about
an issue. Again, you have to have a huge safety team that figures out how to.
I mean, there's some production
already like this
where you would prefer there to be like no oxygen, in these production processes. And so it's like, how do you set up production processes if humans have
suit? Oh God, I gotta go to work with this
that? And it's like the human bot, will just be able to go in there and it doesn't care what the atmosphere is. It could be anything. And reminds me of that movie Aliens. Probably it's a really old dated one that you might remember, where these aliens.
I know that. Yeah,
remember that one. And remember, there was something like that. Is that because they didn't have a problem going into an atmosphere that was like pure carbon monoxide or something like that, going and save everyone, whereas the normal humans could. And that's the sort of thing we're thinking of, is that it'll be different. And again, chip fabs, just think about, you're always seeing the chip fabs. There are people in there, but the fact that
air, anything.
First you don't want the air in there, and everyone's going to be dressed up just right. And of course, everyone has to go home at the end of the day. So you got to constantly go in and out, make sure everyone's clean with these clean room environments. But, you just have a clean room bot and it's in there and that's it. It doesn't have to go home. It just recharges and that's it. And then you can really seal that thing down and just imagine, the purity will go up or your production rates will go up. So there's all sorts of reasons for considering that. And the other thing I should point out is today, Rethink X dropped their paper on the humanoid bot, which is an excellent read. So Rethink X and Tony Seba, they're talking about what's coming. And the analogy they use is like, this disruption, this time, we're the horses, because, they talked about how the horses were replaced by the cars. But now basically us humans, we're going to be like the horses. we're going to be the ones that aren't needed anymore, put out the pasture.
Yeah. I've just looking it up right now. That's why I've wait a second over here. Wait a second here. Okay. Yeah, but that was one of the, I think. And
this is showing that historically all these different, what you really should call X curves, because whenever you have an S curve, there is some other technology which is going on the opposite S curve on the way down. It's just the nature of disruption. It's really hard pressed to think of any sort of technological innovation that didn't somehow supplant something else along the way. Yeah. And that's why the company is called Rethink X, because everything is an X curve. And, they all take these different shapes, but it's just absolutely fascinating. And this is the disruption that's coming to labor, that as the bots go in there. Now, the one thing about it is that they point out sort of a trend we've also noticed is the robots are not going to take our jobs away, immediately. What they're going to do is they're going to fill the labor gaps that we have now over like the next decade. But it's like in 10 years time that then you have to start thinking about, well, actually the amount of human labor is going to go down. But because of demographic reasons right now, we have a problem, is that the labor force is retiring and there's not enough coming in behind, and there's already enough labor shortages even before that. So the demographics are accelerating that, and they're doing it twofold. One is at first, they're no longer contributing to the labor force and productivity, but they're consuming, right? Because they're all going into retirement. Well, wait a minute. It's like, where's all that stuff going to come from that the people going to retirement are going to need? And that is, it's basically going to be coming from the bots. So they're coming to the rescue and fixing that. But that means we now have kind of this
bridge the gap,
frame to start talking about, what did we start doing when we get over to here? What's the retraining going to look like? So it's going to be disruptive, but it's something that can be managed. And they're talking about wanting to get the soft landing. So we really can get kind of the soft landing, and how we get to the other side, which will really be super abundance. I mean, it's just going to be crazy what will be possible there. But for a lot of people, it'll be very unsettling at first of what's happening. There could be some social upheaval, but if everyone understands what's really going on, then you can see that, it's not something that's really going to threaten us. And it's not like the bots are just going to be mass produced for the sake of mass producing bots. There still always has to be an economic case for everything. And in this case, there's nothing is really free in this world. So I'm not going to go out and make a robot army of 1 billion if I can't produce anything and no one's going to buy anything. The economies and everything they all have to balance out. You can't have that much of a distortion to everything. At some point, things come into some sort of equilibrium. But it's one we should be able to manage, and it's one that is really going to be necessary in many cases. And you always hear people complain, it's like, yeah, but you're taking away this job and that job. And I'm like, well, is that a job you would actually take and would like to do yourself? And like, oh no, I wouldn't want to. It's like, oh, boring. And it's like, well, okay. So if it's not good enough for you, well, why do you think we should, force upon other people to do that? It's, if it's a job that no one really wants, then it's something that we should figure out how to automate and make sure that the jobs people do have are jobs that are fulfilling, something that they actually can get an adequate, make a good living off of. So that's why I'm not that concerned about the jobs going to be taken. They're going to be taken the way they want, because right now it's like these companies are having turnover rates of 100%. a year. Okay. And so, that's telling me something about the jobs. People don't want them, you know?
Yeah.
The only reason they take it is because they're really desperate and they just need the job for that short period of time until they are able to find another job that they'd rather move into.
Absolutely. Yeah. I also get it. Also, is the one point is that the companies, don't want to. There's a balance. If we don't go with bots, then the workforce is still shrinking, and then suddenly we can't produce stuff.
It's going to be
anymore.
worse.
And then the prices of stuff actually goes up then because you
get inflation.
Because it gets more luxurious to produce these things because the cost is higher to produce these things, and stuff like this has to be considered very carefully. It's a balance act.
I'm more concerned about what the demographics of what's happening right now and what things would look like 10 years from now as far as inflation and productivity and everything else. That could be a much bigger social disruption than the bots.
True.
So pretty much the way I've looked at it is like the bots are going to arrive just barely in time. Just barely in time.
Yeah, that's why we need them ASAP. Yeah. Okay, Scott.
So literally,
thank you very much.
Ex machina. Okay.
Yeah, exactly. That's true. Yeah. So Scott, thank you very much for being on. For everybody here in the audience, if you have a question, of course, ask it down below and follow Scott on X, preferably. And I will force, of course, Scott to come on this channel again and answer all the comments down below. I will make sure that he's here. Well, so write something.
They go through and look at some of the comments.
Yeah, we can do that. And Scott will be here. I will be here as well. So, Scott, there's only one last thing to say now to the audience, and that's, of course, goodbye, everybody.
Yep. Cheers, Simon.
Ciao.
Wasn't this episode awesome? Let's accelerate the pace of innovation by subscribing to TeslaFix. It is my absolute favorite channel on the whole interwebs.